everybody, this is Miss Nicole with Science Bytes, and today I'm going to do a little demonstration called Water on a Penny. And if some of you recently picked up our little STEM bundle bags at our curbside service at the library, you know exactly what I'm talking about. It's a very simple demonstration you can do at home, and it teaches us a little about surface tension and cohesion. But before we do the water on a penny, I wanted to show you a little science magic trick. And for that magic trick, I will need an empty mason jar. The lid is off, so this is just the jar itself. A card of any kind. This was one that just came with my mason jar kit, but you can use any sort of card you want. And last but not least, a pitcher of water. You can see it swishing around in there. So the first thing I'm going to do is pour water into the mason jar. That should be good enough. Everybody can see that I've got water in the mason jar. Now I'm going to put this card on top of the jar, flip it upside down, and I'm going to predict that the card is going to stay in place without me having to move it out of the way or hold it in place once I turn it upside down. So here we go. It's upside down. Let's see if my prediction is correct. Look at that. And now what I'm going to do is remove the card from the mason jar, and I predict now that the water is going to stay in the jar with the mason jar turned upside down. Let's see what happens. Look at that. You can see that the water is still in the jar without me doing anything. Now, if I turn this jar even a little bit at an angle, that water is going to come out. Watch it. Here I have a bowl. And watch this, if I turn it just a little bit, there goes the water. So what was happening when we did this with this demonstration? So when I had the water in the mason jar, and I put the card underneath, and the card stayed all by itself, something called atmospheric pressure was holding it in place. And that means that the pressure of the air pushing up on the card was actually stronger than the pressure of the water pushing down on the card. So the card stayed in place without me holding it. Now, when I pulled the card away from the mason jar, what we saw was a demonstration of both cohesion and surface tension. And this is why this is a little bit of a science magic trick, because what you didn't see in this jar, and I'll show the camera, is that I had a fine layer of mesh right here in the mouth of the jar. And what this helped our water molecules do was to sort of form a little blanketed grid between all those little open squares and create an area of surface tension. So there was a thin film on top of that surface of water. And we also saw a demonstration of cohesion. Water molecules want to attach to other water molecules. They want to connect. Picture two people with their arms locked together. That's what water molecules constantly want to do with other water molecules. You may have sometimes seen a drop of water on a surface and two drops of water slide towards each other and form one bigger blob of water. That is cohesion. Those water molecules want to attach to each other. So now the second that I tilted this mason jar, we broke that very thin film, that surface tension, and all that water came pouring out. So now we are going to do another very simple demonstration of cohesion and surface tension using a penny and a little eyedropper and some water. And now I'm going to show you the water on a penny demonstration. And it's very simple. You need just basic supplies. You need a penny, and the shinier the better. I think they look better when they're shiny. And you also need something that's similar to my micro pipette. And micropipette is just a pipette is just a fancy word for eyedropper. When I squeeze this and then stick it in water, it'll suck up the water. But if you know, how many of us have these rolling around at home? I just happen to have a supply of them. But you can really use anything that's going to put drops of water onto the penny. Maybe it's a Q-tip or a straw or even a paper towel if you wanted to squeeze it in little bits and have water drop down onto the penny. Anything that you can have drops of water coming onto the penny from is fine. And I've got a glass of water here. And these micropipettes, just for your information, I usually buy them from Amazon. And they come in, they're not very expensive, and they come in packs. This is a pack of 100 pipettes. So if you wanted to keep doing experiments at home, pipettes are a really handy thing to have. You use them in a ton of different experiments. But we do have some extra ones at the library, so if you happen to call on a week when I'm working in the library, we're doing rotating shifts right now at Prosser and McMahon. You know, give us a call, and maybe we can even put a pipette and a penny in curbside pickup for you if you wanted to try this at home and you didn't get a chance to pick up one of our STEM packs earlier in the past weeks. All right, so just give us a call, and we don't have a lot of supplies, but you know, while supplies last, first come, first serve, we might be able to give some of you, you know, a pipette and a penny to take home in curbside. But now for the demonstration, very simple. I'm going to put water in my pipette, and I'm then just going to drop water on the penny. And I'm doing it one drop at a time. The nice thing about a pipette is you can do some nice tiny drops, and you don't have a lot of water going on all at once. So if you wanted, you could count how many drops you get onto the penny at a given time. And you are going to see, there we go, you are going to see that the water domes up onto the penny and doesn't spill off right away. It actually, we get the surface tension, which is that thin film that sort of surrounds that top layer of the water, and then the cohesion of the water molecules where they want to stick together. And so you end up getting a big dome of water on the penny before it eventually becomes too much and it spills off the penny. But before it spills off the penny, you'll even see that the water sort of goes over the edge and then creates the dome. So that dome is even going over the edge of the penny a little bit and is still holding its shape because of the cohesion and surface tension. So we'll do it one more time, and I'll show you some close-ups as well so you can really get a good look at what's going on. Again, here's another time, another demonstration. Again, we're going to put lots of drops of water on the surface of that penny, and you're going to see that it builds a dome of water on the surface. And I even have to go back and get some extra water because I'm able to put so much water on the surface of that penny, a flat surface. Look at that, I'm still, and there we go. I think that one was my fault because I actually squeezed the water droplet a little off to the side, and I think it took the water with it. But you get the point. You can see what's happening. So give this a try at home, and you can also try it, if you want to take it a little further, try it with things other than just water. Maybe try a little bit of vegetable oil or alcohol, rubbing alcohol, or try some other, try some juice or some milk and see if there's a difference in how it responds to surface tension and cohesion and what it does on the surface of that penny. So that's it for this edition of Miss Nicole's Science Bites. We learned about surface tension and cohesion today and a little bit about atmospheric pressure. So stay tuned. I'll have another edition of my Science Bites in a couple of weeks, and hopefully you'll enjoy it then. And by all means, let me know if you have anything that you're curious about, and I'll see if I can do an edition of Science Bites to help you with those questions. Until next time, bye everybody.